Hi, I'm DJ Ware. On this episode of the CyberGizmo, I'm going to be looking at some tools and some Linux commands for those of you that maybe are interested in learning more about the command line and using the terminal in order to interact with Linux more. So stay tuned right after this. So I've got my old friend here, the terminal screen up and running, and while we're sitting here at the terminal screen, I'll just explain a few things to you. So, first thing is that you'll notice that this is here. This whole thing from the $ over is your shell prompt, and in my case, it has a bracket, a square bracket, or a brace, PI. Which is the pi, which is the name of the user, @ and this is the host name, and then the tilde is the default location in the directory structure where I am. Tilde is always a shortcut for home, and then I have the actual, and then I have a closing brace, and then a $, which of course is the pound, which is the prompt for the shell, and then a space just to make it more readable. So some basic commands that I can do here. I mean, I can start with the ls commands, but let's start with something a little bit more useful. So let's say that I have a number of machines on my network and I'm using SSH and I have that installed. You probably already know how to do this, but you can, for example, I can SSH to pi. Let's go over to one of my other machines. And if you have an etcissue.net file, it will display that when you first connect to the machine. So the shell, the secured shell, has connected to the server on Blue Ice, and Blue Ice has automatically displayed with the contents of the etcissue.net file. If you have one of those, you can have it do that. You can put all kinds of information in there. You can put fancy text or blocks or whatever you want in there. So whatever you like. I just have some noise words here that satisfy Linus in order to do it. So now I have a terminal shell that's actually into Blue Ice, and you'll notice that my terminal prompt has changed. Fedora uses a different default one from Ubuntu, and this comes from a variable. We can echo it, called PS1, and this is all the stuff that is in it, and these are actually execution statements that are in this PS1 variable in order to generate a dynamic shell prompt. So yeah, so I can go out here to my, you'll notice that it changes. I can go and it adds on the user, and it just keeps adding it on. Let's back out a minute. Let's go to share, probably more in there. Yeah, so you can keep track. It's kind of like a breadcrumb trail to show you exactly where you are in the file system as a reminder. And then, of course, you have the $ prompt here as well. There is another one called PS2. I think sometime maybe I'll go through all the environment variables for you, but I mean, today we'll kind of cover some of that. So I'm going to go ahead and exit out of this. Let's say that I don't want to log in anymore to that. So I can look in my SSH directory here. And on my local machine, I'm back on the Fedora box. And you'll notice I have authorized keys. I'm looking at .ssh, which is that it contains the keys and known host files for any of the systems, and also a config if you want to set up some names or something like that for which user IDs you use to log into those boxes. But if I wanted to, I already have an ID file, and the way you would generate one if you don't see an ID_RSA or an ID_RSA pub, you can name those anything you want, but those are the default ones. So you can do a keygen, and a keygen it'll start to create a new pair. So let's create a junk one. Well, I don't know. Maybe. So anyway, you'd give it a name. let's say, something like that. And generally you leave the passphrase empty, because if you don't, if you put something in here, then every time you still have a password, basically. So what we're trying to do is to get away from using passwords to connect and using keys to connect to SSH instead. So that means that I have to transmit the ID RSA is your private key, and the ID underscore RSA.pub is your public key. So once I generate this, it will create a file. Now, I hope it didn't, I don't think it disturbed this. No, it didn't. But in my home directory, I should have junk RSA and junk RSA pub. So what I can do, now I'm going to ignore those for a minute. In fact, I'm just going to go ahead and get rid of them. I just wanted to show you how to generate them. Normally, you would take the default and put it inside of you put your ID RSA inside of your .ssh file. The next command you would do is a copy ID, and then just put in the login name that you would use to talk to, just like you would for an SSH. And what it's going to do, it's going to ask me to log in because it hasn't transferred the key yet. Now it has transferred the key. You can see that it's set. Now the X11 for requested, just ignore that, it's nothing. But the number of keys added is 1. So now I should be able to do no password. I can then, if I wanted to, if I can have certain machines that are only allowed access, so that I would have to connect to, let's say I made Blue Ice my main machine, and I could turn off the login in SSH D in the config so that it was forced to use the key all the time, which means that no one could guess a password to be able to break into the system. They would have to have the public key in order to access the system. Now that creates the challenge, of course, of how do I get the public keys to the users that want access, or to more specifically to the machines that want access. But anyway, I just wanted to show you that. So that's number one. The other one is that is PWD. PWD will show you where you are in the file system. Let's say I go down here to bar lib. Oh, I don't know. Let's go to RPM. There's probably a number of stuff in there. So I can do a print working directory, and it'll show me what my current location is var libs RPM. So I know. Even though my tracker here is showing me I'm in RPM, that I can always get the full path name of where I am. The other one is, the other commands that I can do is who. Who shows me who's logged into the system at the moment. So right now, a user called Pi is logged in, and they've been logged in since 2020, 0429 at 1423. It's currently 5:58 here right now. So yeah, so I've obviously been on the system for a while, and that will update if I log off. The other thing I can do is, this is not really all that useful. It just shows me the first part of this command, which one of those users is me. The other thing I can do, I can get more information about my account, such as I can see the UID, which is the user identifier, and also the group identifier, and then what groups I am currently in. The default one, of course, matches with the one over here, which is Pi, member of Wheel, audio, Jack user, LiveVert, context is unconfined, and then some other stuff out here. But the ID will give you information specific to that user account. If you want to move around in the file system, we kind of did that already a little bit. I'm doing a CD here, and I can then do a print working directory. I can then list, and I can see that I am in the root directory for my system. I could move to, let's say, user 2. And I can see what's in that as well. These are ISO files that belong to the cluster to help set them up quickly if I want to. A quick way to get back home, now I could just do a CD by itself, or I could do let's go out here, I could do a CD tilde, which will take me to my home directory. There's my home directory. LS, of course, we've talked about that. That's the list of the file system. We've talked about that in the past. There's a long form of it where you can actually see information about the directory itself. You can find, the permissions and the user and the group and the size and the date it was created or modified, and then the name of the file itself. I can also look and see which ones are hidden. The normally hidden files in Linux begin with a period or a dot. If I just do and you'll notice that var is not listed here, and it only shows up, the .var only shows up if I do the -a. I can clear the screen. I can do this a couple of ways. The old way of doing it was to do a tput clear. This is the Unix way of doing it. It still works, but a lot of people just use this way. I'm a creature of habit, so I still use the tput clear. So if you notice, if ever I'm clearing the screen, you'll probably notice I do that. It's just habit. And that comes from the reason for using tput clear versus clear. Tput clear is the terminal put, and it actually, if you're on a physical terminal, that tput will actually look up the commands needed to clear the screen and position the cursor at the top of the screen. And that goes way back onto Getty and serial terminals back in the day. So let's see what I got here. Okay, so I've got some files here. What if I want to see what's in it? One of those files. I can do a cat, which is the concatenate command. I don't know what Linux calls this. Let's see. What does Linux call this? Yeah, concatenate. I don't think I've ever looked and see and actually saw what Linux calls this, but yeah, Unix is always the concatenate command, and cat was always used in order to append one file with another. But anyway, that's neither here nor there. So. But you'll notice that when I did that cat on the scan list, it was longer than the terminal screen, and all it did was it just rapidly scrolled up. Well, that's great if my terminal screen has enough buffer to contain it all. But in this case, I've lost the buffer, so what do I do here? Well, let's compare out my command again. I can pipe that to more. And more allows me to use the spacebar to go through the file. But using more this way, normally I could hit a B command to reverse the direction of the scroll. But because I'm using cat, it doesn't have the buffer. It's only, yeah, so the proper way to use this would be like that. Now I can scroll forward using the space bar, and I can use the lowercase b to scroll back to the top of the file. Simple as that. Oh, one other thing you can do. If you're using more directly, I can do a search for var. And one of the complaints that I've always had about more is that, where is it? Where is the search pattern? Where did it appear? So less was invented in order to solve that. Yeah, you don't fix the command, go out and write a new one, right? So less will actually, if you put in a slash, this is a search pattern. I'm looking for var, and it'll actually highlight where it is, and then I think I can, well, maybe I can, yeah, just keep repeating with the slash, and it'll keep looking through the file. I think that also works in reverse, too. Yeah, maybe not. Maybe not. Okay. So as they say, if you look at it used to say the opposite. It used to say less is more on Unix systems. It says less is more. But that was the reason for less, and that's one of its differences, is that it actually highlights the search pattern. Let's see. Talked about that, and we kind of touched on this a little bit. I did a man. These are the man pages that are in your Linux distribution. You can do a man, which will show you how the actual command man is used. This stands for reference manuals, and these have a certain. This has a format that has been with us since 1970. So let's do it, man cat. And generally, it gives the name, gives a synopsis of the command structure, and then a brief description. And if the options, typically, nobody follows this convention anymore. I mean, I've seen man pages all over the map, but it used to be the name was the name and a brief description of the command. And then the synopsis was, this is how you would normally execute the command. And anytime you see a square brace like this, that's an option. It means you don't have to have anything there in order for the command to work. But if you supply it, it will use it. So it wants the options first, and you can have as many options, that's what the dots are for, and as many files as you want as well. 0 or more files, 0 or more options is how you read that. But that would then take whatever's in the file and sends it to standard out, whatever that might be. And in this case, it's my terminal window. So I can show tabs, I can show non-printing characters, which be careful with that on terminals because non-printing characters are commands usually to the terminals, and they can send your terminal into an unstable state. Or it might do something to the terminal like reserve areas on the screen, or maybe transmit only unprotected areas. So yeah, you can get into some pretty funky stuff there. Let's see, done, man. All right, let's do another one. Let's do this one, man copy. Copies files and directories, probably have all seen this one. There are options, and you can preserve the archive. You can have it do recursive down through a directory tree if you want. So let's say I just want to, let's see, let me find, I think I have some test files here. Yeah, let's copy test0.shell. And I can look at those. By the way, a question mark is a substitution for a single character. So what I'm saying here is, give me a list of everything that begins with test, and then I don't care what the character position is following test, but it has to have .sh after it. So now I can see test 0, test 2, and test 4. Test 4 is the one I just created, and it is identical in size, should be 23 and 23 to test 0. But how do I know they're the same? Well, we can use the diff command. And if it comes back blank, there's no changes. Let's do a diff between those two. So you'll notice that there's these little carets here. So this one is coming from the second file. This one is saying that if I look at test, it has echo junk in it. If I look at the first one, there, it has the first line. So this one, the caret directions have to do with the order of the file. So if you see a left arrow, it's coming, then that is the contents of test 0. And it's comparing line by line through the file. So it's saying the first line of test 0 contains this, and test 2's first line contains that. This means there's no match. So yeah, there's no matching text. If there is a match between them, it doesn't display anything. It doesn't display anything at all. So that, as in most things with Linux, no news is good news, right? So let's say I'm done with that file. I can remove it. Let's say that, let's say we want to copy, I think I have a Vagrant directory here. Yeah, I do. So in that Vagrant directory, I have just some Vagrant files in a README. So let's do a copy. I'm going to copy the entire contents of Vagrant, and I'm going to put it in and there's my new Vagrant. So once I was done with that, I can attempt to do this. But as you see, I'm going to get an error here. How do we deal with that? Well, if you look at, and you have to be careful with this one. I need to remove the files recursively. So I'm going to need a -R. Is that enough to make it work? No, because it's write protected. It's asking me if I want to go ahead and remove it anyway. There's some hidden files in there. Or I can just say, just go ahead and blow it away. And now that directory is gone. The -F is forced, and be careful where you do that. if you're out here and you do it, it will have enough of your system blown away that you won't be able to reboot. So before you can catch it. Fortunately, you do have to do a sudo to do that. So, all right. So let's see. What if we want to find out what's running on the system? We do a ps-ef. Not very useful, is it? I mean, there's this whole big mess here that is showing me everything. What if I just want to see jobs that are owned by me? Okay, so I'm doing a search on Pi, and that's picking up, it doesn't care where it finds Pi. It can also be, as you can see right here, it can also be in the middle of a directory name. But what if I want, I don't know. What if I want a specific thing? Let's say I'm looking for ops. Let's say I'm looking for OBS. I can do a grep, and a grep is a pattern match. It just matches patterns. So this is probably your first foray, if you've ever used grep before, into pattern matching. Now this is not regex. Regex is something quite different. But this is a pattern match to look for it is a form of regular expressions, but regular expressions is deeper. It's a lot deeper than this. So yeah, you can use regular expressions with grep, and you can use regular expressions with a lot of Linux commands. One of the inventors of Unix was a natural at regex, and yeah. And so he liked it so much that he put it into everything. There are books on regex that are about that thick, if you're interested in them. Some other things that you can do. I have some let's see. Let's see my test. Let's see what test 0 does. It just concatenates. Oh, so what's going on here in this script? So, okay, let's just type it out. So first of all, if I were to run test shell, it's going to give me command not found. And why is that? Well, there's a variable that controls what path your system looks for files to execute. And even though my local directory is not in here, even though my home directory .local is there and my home directory bin is there. So if I had this in the bin directory, it would execute, but because it's out here, it won't. There's a shorthand called the dot, which allows me to say right here in my current directory, this is where to look. It doesn't tell, so Linux won't look any further for that file other than in my current location. So this time it's running. It didn't print anything, but let's see. Let's do the original one. Okay, so it prints junk. this command says to take the output, the standard output from test.shell, and pipe it to the input, the standard input of test2.shell. This is probably one of the most powerful things in Linux as well as Unix. It was through this that you could take pieces of information out of one file and send them to another program, and you can just do this all day. I mean, I could just keep sending the output of that one to another one until I got the data that I wanted. Yeah, same problem. Okay, so it did its thing. What if you wanted to run that? Let's see. So I want to run this command, test0.shell, and I don't want to wait for it to complete. Maybe this is a really big list of things that it's working on. I can run it in the background, and it'll assign a job for it. And you'll notice that, I mean, that command probably ran, but nothing's happening on the shell. Why is that? Well, it turns out the shell doesn't actually update the background jobs until you hit enter. And so when you do that, then it says, oh, that job that was I just put in the background, it's done. And so if I do a PS now, that job will not be there. You can also look for jobs that are running in the background by just typing the word jobs. And if you do have backgrounded jobs, it'll do that. So basically what this does is it runs the command, but it returns the control to me on the shell. So if I had a long running command and I didn't have that, I'm stuck waiting for the output to complete. I'm waiting for that application to complete. So that's the difference. Let's say, okay, so I'm doing a search for bash, and this is my search, my grep right here. This is the search that I did for bash. This is the actual bash script that I'm currently running. So, yeah, I think that's the current one, 12.4.4.7.1. If I were to kill that, it's going to kill my terminal session. Now, there's different, kill is the command to do this. There's, at this point, let's see, I don't know if they'll show it to you. So you can tell it what signal you want to send to the process. And anything from a -1 is the same as doing a control C. So if I were to do a kill -1, and that was 12, I'll just copy it. It's the other thing, the other short, except don't do it that way. Okay, so that's the same as closing the window, and the shell command responded to it. So it closed my window. There's different levels of this, and you can read about those. I believe there's maybe I should put some information in here for you to do that. So now that bash is gone, right? So if I do a PS now, I've got a new bash number here. So I can look for the PID. I still got it in my copy buffer. It's not there. So because it killed it, it removed it from memory. There's also, I can also do anything above -9, -11, -12, -15. Those are crash out, and you should be careful when you use those, because you're basically pulling the plug on the application. A -1 is just an event. A -1 is a term event, and your application can intercept that interrupt and then do whatever housekeeping it needs to do before closing down, like writing out the last bits of data to a file and then closing the file correctly and then bringing down the app. A -9 doesn't give the application any chance at all. It tells the Linux scheduler to remove it immediately from memory, to pull the plug on it. So, yeah, if you've got a database or something that's running, or something like that, be judicious about using a -9 because you could corrupt your data doing that. Just saying. But this is a shell. I don't care if it corrupts this. So I'm going to kill the shell that I'm currently in. It works the same way. The difference was in how fast and what type of interrupt and how the interrupt was processed. Crash out interrupts immediately stop the process. It does not give the application any chance to do anything with it. There are some exceptions. There is a halt and a power off signal as well that will go to the application, and so those will tell your application, allow your application to clean up. So, all right. What about IP addresses? So basically, we're in networking today. Now, I mean, I can go here, and I can go to my stuff, and I can bring this up and get a nice GUI window and look at it. And I can go in here, and I can look at my IPv4 or my IPv6. But you'll notice that when I get into DHCP, it's not really giving me any information here, is it? I mean, it just tells me, oh, you've got DHCP turned on, and it's looking, and it's automatically filling it in, but I don't know what the settings are. How do you get that? Well, the old way, and it still works, is ifconfig. That's the old way of doing it. That's the Unix way of doing it. In fact, BSD OS, the BSD OS was one of the first ones to do this because they were the first ones to have Telnet in it. AT&T Unix went off on streams. They went a completely different direction from sockets. And Berkeley was the one that came up with sockets and came up with this. So it's been around a long time, but the new and improved way, the new and improved way is to use IP. And IP will show you, there's my loopback, there's one of my network addresses or devices, there's another one, there's a virtual bridge, and then there's another virtual bridge. But what if I just want to see, I think it's 4, is that right? 4? Yeah, 4. Been a while. So this will show me all the TCP IP version 4. My local address, this has my internet address here. It has my bridge or the broadcast address. And then whatever variables are set in the these would be command options that are set for that particular device. But what about if I want to see the IPv6? So in this case, it's going to show me the INET 6 device, and that's the difference. INET is version 4, INET 6, and then there's my IPv6 address. And then it gives you also the maximum transmission unit, 1500 bytes, and then all that kind of stuff. So it gives you a little bit more information, but it still doesn't tell me anything about the routes, right? So I still have to do this one. Let's see, I think it's I. Okay, we'll do that. So this one's showing me my actual my devices that are routing and where they're actually going to. And I have these these are broadcast addresses as well. And then there's the virtual bridge. The virtual bridge in this case is being used by KVM. So yeah, if you install KVM or Virt Manager, or I believe even VirtualBox installs a virtual bridge as well. So, and those are used to provide private IP space within the virtual machines. One command that you'll always find that you will never have to install is this one is top. If you just want to find out what's running on your system, you can do that. There is a help for that as well. So you can accumulate the statistics. You can delay how often you want it to refresh. And there's, some general information here about, you can change the colors, you can bold it, you can do summaries and all that kind of stuff. And then escape will come back. So if I hit it, like I've shown you this before, if I hit a 1, it'll break down the CPUs and show you what's going on with each one of the cores or the threads that are running on the machine. But let's see. What about it? But you'll notice that it doesn't tell me where that location of that package is. It just says this is the command that's running. There's where OBS is living. It's in user bin. I can do the same thing with Reaper. Probably because that was executed from, I'm going to guess it was because it was executed from a script. So that's why it's not showing it. And it's not in my search path. Yeah. So which is only going to look at your search path. So remember this. It's only going to look in there for it matches. And if it's not in there, it just reports it's not found. So I showed you the dollar path. I guess I should show you this. If you want to see all the environment variables that are set on your machine, you do an env. Now I'm going to pipe it to more because there's a lot of them. And these are the settings that you can mess around with in order to change how applications react to different options that are given to them from this environment. And this is set up during your initial login. It's either configured in the bash profile of Etsy or the bash RC of Etsy, or the .bash RC or the .bash profile if you're using bash. Also, .zsh has its own, and there's some others, K-shell, C-shell, they all have their own places for finding this. But if I look at you'll notice that this is a shell script that is actually assigning additional locations to the path, and that's how they get in there, and how it sets up this env. And of course there is a default. There's also keyboard shortcuts, command aliases, all this kind of stuff. The colors that are used by the terminal, everything is defined here. So if you ever want to know more about how Linux works, this is a good place to start, is learning what all that does if you want to modify it and change it to the way you like things. So the last thing, I think the last thing I really want to do today is, what if you're looking for a file? And all I know is a partial name, but I have no idea where it is. Let's, like Reaper, for example. So let's do a sudo, because I'm going to need system permissions to read all the directories. And I'm going to start my search since I have no idea where it is. And then I'm going to put in a name. We're going to find it. And then I put in a print which says, when you locate it, tell me where it is. And now it's going to cruise through my entire system looking for Reaper. I found it in the backup. So yeah, I did pause that for a minute because this file system is really big, and yeah, it would take a long time for it to do that. So basically it found it here. There's also a copy of it here as well. So yeah, so that's all the occurrences of Reaper that it could find. You can also do that a different way if you want. You could do a Grep minus I. Let's say I want to find something that's in it, in a file. So mine, I'm going to look for, I don't know, I guess I had junk in one of the scripts, right? So let's look for that. And then I'm going to pass that list of files that it finds at the Grep locates. It's going to pass the file name to find. And I put in a dot. Oops, not that. And I'm going to restrict this. This / is an escape, because a star says it's a substitution character. There's a lot of special characters in Unix that have meaning on the shells, and that would mean to expand that asterisk to all the files that it finds. And I don't want that. What I want is I want to pass the star directly to find and let find do the parsing, but to parse it as star.sh. Not to say, it would be really bad. I guess I'll put the print command back in here again, and then I'm going to close this off. Now, these accent marks here are special because it says execute what's between them. So normally it would just take it as text, but in this case is saying go execute that. And so, yeah, what it's done is it's showing me everything that has contents of junk in it. So this is the contents of the file that it's looking for, as opposed to the file name. So yeah, you can get Linux is quite powerful in finding and locating things. A couple other commands. Let's go back to my scan list here a minute. This thing. What if I want to just look at a few lines of the file, like the first maybe 20 lines or 30 lines or whatever it is. It's about 20 lines. So I can just do a head, and I don't have to look anymore at the file. There's also the converse, which looks at the tail of the file. And then so you can look at the start or the end, and I can pass it that I want the last 200 lines of the file, or maybe there's an active program that's running that's appending records to it, so I can just sit there and watch as new things come into it. So there's some things that you can do with your files. The tail is really useful for the old-fashioned logs. And the next time, I think I'll get into some of the journal commands, because the log files are changing. Fedora has already changed it. You'll notice there is no syslog here anymore. Syslog is gone. So, yeah. I think I got into this a little bit the last time, and I can look at the end, and that will look at all the logs. It's a lot easier than it used to be, because you had to go and look at this log. You had to go look at the audit log. You had to go look at the security logs, whereas this has kind of combined everything together. And then the -E is just monitor it. Just keep appending to it every time there's a change. Yeah, so I can watch all the logs on the system if I want, and it's a nice way to do that if you get bored. So I think that's probably enough for today. I think what I'm going to do is kind of listen to you guys and see what else you would like to know about. There is one other thing. I'm sorry, I missed something. So yeah, I missed something. So there is another command. We have top, right? And I meant to talk about this, but what if I want to see what's going on IO-wise on my system? So there is a converse up top, and it's called IOTop, and you'll probably have to install this. I don't believe IOTop comes installed on most of the systems, but this is similar to top, but it's for IO. So I can, you do have to be sudo because you are opening devices. And in this case, it'll monitor all of the disk traffic that's on the system, but it'll tell you what applications are using it. So you can see right here that, of course, OBS, yes, OBS is writing a heck of a lot to the disk right now because it's recording. So yeah, that's what's going on there. So anyway, that's a very useful tool, and you can scroll down through this if you want. But it does not have, you can't really single out anything. You're just looking at the top listings. I don't know if there's any help here. No, there isn't. Yeah, this really needs to be expanded to make it more like top, where you can have it go and look for specific applications and see what they're using. But what it does instead is it just puts the ones that are really chewing up the systems on top, which is probably the ones you're probably interested in anyway. So yeah, that's all I wanted to cover today. And if there's some commands that you'd like to know more about, let me know. I mean, I'll keep finding good stuff for you if I can. Those are the ones that I like to use on a daily basis, and I'll get more back into the journal control next time that I do one of these. And I hope you enjoyed this topic today. If you did, please like and subscribe. Hope to see you all again real soon. And as always, stay safe and healthy, and bye for now.